that, here we've got our agenda for the week. And you'll notice that we are now starting Unit 3. And it's a pretty short unit, right? We're starting it on Monday, and we're going to test on it this Friday, July 11th. It is now July 7th. Our very last day of the summer term is the 25th. So we have 3 weeks left when you count this week. So we are really getting kind of towards the end of our term. In the middle of this week, we will be about 50% done. At the end of this week, we're 60% done. Hey, Kayla, so good to see you. I'm glad you're here. Yeah. So we were just saying how short this unit is, okay? Unit 3, which is about energy, it's going to last for 5 days. And we're getting there towards the end of the summer term. So Unit 3 is all about energy and work. We're going to describe energy today, learn how to calculate energy, and then talk about how energy is related to work. And then we'll kind of wrap up the unit on energy, talking about machines and how they make our work easier, okay? So that's kind of where we're going with this. So we're going to define energy and work today. We'll talk about different types of energy, define conservation of energy, and give some examples of how energy can be transformed into different types of energy, and explain how kinetic and potential energy are related. Hey, Bobby. So glad to see you. Glad you're here. So if you would, go ahead. I'm going to share my screen. Remember how to get to our notes today, right? If you are at our home page of our class, just again, click on courses, go to our home page, which is right here, click on announcements, and you can see there's a new announcement. It says week 3, July 7th through 11th. And today, Monday, July 7th, we're going to be working on notes 3A, describing energy. So if you would get those open, and then click on that tag and let me know that you are ready to get started with our notes. Okay. Thank you, Jordan. I appreciate you. Hey, Seuss. Your timing is impeccable. We're just now getting started. If you would, go ahead and open up your notes for 3A, describing energy. Thank you, Kayla. I appreciate you. Olivia, Bobby, Jesus, Thomas, Vanessa, let me know when you are ready by clicking on the activation tag up here in the upper right-hand corner, and then we will get started. Thank you, Thomas. I appreciate you. Perfect, perfect, perfect. Okay, let's do this. So, how do you try to gain energy when you're tired? Okay. I know I spent this weekend, my 3-day weekend, I really used my time to gain energy. I slept a lot, right? You could also drink caffeine or maybe eat some sugar, right? Um, and I know that when I eat food, I'm actually taking in chemical energy. Chemical energy is stored in chemical compounds and released in chemical reactions when my food is being metabolized. Okay. This is question number 2. Um, I'm going to stop this file share and I'm going to open up a different file. I think, yeah, that's why. I had the wrong PowerPoint open. There we go. This will be a little bit better. Okay, there you go. Now you've got the boxes blanked, right? Yeah. Okay. Hey, Cyrus, good to see you. Your timing is impeccable. We have just started our unit 3A notes describing energy. Okay, so go ahead and get those open. And then we will get started. So this is unit 3A. Okay, unit 3A. I'm going to go ahead and put the timer on, give you about 30 seconds to finish this up. Okay. So with chemical energy, remember that when chemical reactions occur, they're either going to be endothermic, meaning that the reaction is going to absorb energy from its surroundings. Or it could be exothermic and release that energy into the surroundings, right? So a great example of exothermic is the batteries in a flashlight. When we change that chemical energy into light, we are releasing some of that thermal energy in the form of light. Okay, so give me thumbs up. Are you done with question number 2? Give me a thumbs down if you need a little bit more time. Thank you, Kayla. Thank you, thank you, thank you. Perfect. Okay, so that is question number 2. I appreciate you guys. Thank you, Thomas. Okay, so here is question number 3. Another type energy is electrical energy. And when we talk about electrical energy, we're talking about the movement of negative charges. Okay. And so I know that electrical energy powers my house, my light bulbs, my laptop, my electric car, all those things. And the electrical energy is typically generated from other energy sources like oil, coal, and nuclear power plants. Okay. Hey, Olin, so good to see you. Thank you, Olivia. Thank you, Kayla, Jordan, Olin. Thank you, thank you, thank you. Vanessa, Thomas, Jesus, Cyrus, Bobby, are you good? Ready, ready, ready? Perfect. Thank you. I appreciate you. Okay. So that's question number 3. Another type of energy is the thermal energy, right? And this thermal energy, we talked about in Unit 2 a little bit, how temperature is a measurement of the kinetic energy in a substance, right? So this activity of a substance particle is the thermal energy. When things are very, very hot, those molecules are moving really, really fast, and they are colliding with each other. Okay. Okay. When a material is cold, the molecules move very much more slowly, and they collide with less energy. Okay. So remember that it doesn't matter what state of matter it is, all particles do vibrate to some extent. So even your solid desk, those particles are vibrating slightly. Okay, awesome. Thank you, Olivia and Bobby, Kayla, Jordan, Olin. Thank you, thank you, thank you. Vanessa, Thomas, Jesus, Cyrus, you good? Ready? Yeah? Thank you. Thank you, Thomas. Okay. Another form of energy is our energy. So when we talk about light, and we're going to get more details in that in Unit 4, but light energy is a stream of photons. They're little packets of light that have no mass. Okay. And they travel very, very, very fast. Okay. Um, Generally, heat energy and light energy kind of go hand in hand, but they are not the same thing. Notice that light energy includes radio waves, microwaves, as well as our visible light, X-rays, gamma rays. All of these are included in light energy. Okay. Thank you, Olin, Jordan, Kayla, Olivia. Thank you. Vanessa, Thomas, you good? Jesus, Cyrus, Joaquin, hello, hello. So glad you're here. Thank you, Bobby. I appreciate you. Perfect. Okay. So with that, we also have mechanical energy. Mechanical energy is the energy of motion and position. And we include two types of energy when I talk about mechanical energy. Kinetic energy is the energy in an object because it is moving. Remember, anytime we see the word kinetic, I'm always talking about motion. Okay. So kinetic energy can be motion of particles, or it could be something like motion of a roller coaster. Okay. And then we have potential energy. Potential energy is the energy in an object that's stored due to its position or height above ground. Okay. Position or height. So those are the two types of energy that are found in okay. So give me a thumbs up if you are finished with question 6. Give me a thumbs down if you need a few more seconds. Okay. Thank you, Olivia. I appreciate you. Vanessa, Thomas, Olin, Kayla, Jordan, Joaquin, Cyrus, and Bobby. Are you guys good? Are you ready to move on? Okay, I'll hold up just a minute. Yep, yep. Perfect. Thank you, thank you, thank you. I appreciate you. Okay, then we have sound energy. Okay. Energy of sound is what causes the air molecules to vibrate. And when that air, those molecules that are vibrating, when it hits our tympanic membrane, our eardrum, that's when we perceive it as sound. Okay. So you can see that it's our brain, the particles hit our eardrums, and then our eardrum starts to vibrate, which then starts vibrating the bones in our inner ear, and that translates into our auditory nerve. Okay. Thank you, Bobby. Thank you, Olin. Okay, don't forget to click on that activation tag when you are finished. Okay. Perfect. Thomas, you good? Yeah. Olivia, you doing okay? Thank you, Bobby, Jordan, Olin, Kayla. I appreciate you guys. Yep. Okay. So here I'm going to show you a video clip of a non-Newtonian fluid. And this fluid you might have seen, it's called oblique fluid also. Some people also call it the slime, although it's a little bit different than real slime. But what they're going to do is they're going to take this non-Newtonian fluid and put it on a speaker. And the energy from the sound of music is going to move this fluid. Now, what's really unique about this fluid is it has the characteristics of fluid, but it also has characteristics of a solid at the same time. And you can actually make this non-Newtonian fluid at home. Okay, so here we go. Okay, so that's non-Newtonian fluid. Looks like it's so much fun to play with. But you can see the energy being released from the sound of the music through the speakers. And that energy was translated into that non-Newtonian fluid, creating peaks and valleys and all sorts of monster displays, right? Okay, so when we look at electrical energy and sound energy, kinetic energy, light energy, all of these things can also be transferred from one form to another. So I'm going to share my screen with you. And here you can see I have a pipe, right? It's going to release some water. And when it releases water, it's going to turn this water wheel, right? And that, so the water that comes from the pipe is going to have potential energy because it's higher than the wheels of the water wheel. Once it hits the paddles on the water wheel is going to turn. That changes into kinetic energy, energy due to motion, right? And that is going to be transferred in the generator to electricity. That electricity is going to change then into thermal energy in this little stovetop, and it's going to heat up some water. And that water is going to raise its temperature. Okay, so again, we can see how the different types of energy are being transferred from one type of energy into another. Again, we've got potential energy transferring into kinetic energy, into electrical energy, into thermal energy, right? And so again, you can see these different forms of energy, right? Mechanical energy. Remember that mechanical energy includes potential energy and kinetic energy, electrical and thermal. We can even change this to somebody on a bike. So here we have the chemical energy that the girl ate for lunch being changed into kinetic energy that she's using to pedal the bike. And that is also turning this wheel, which then gets transferred into electrical energy, into thermal energy. Notice that the girl ran out of energy, but when I feed her, then she gets more energy from her food in the form of chemical energy. We can also change this to sunlight, right, in the solar panel. And collect that energy in the form of a electrical grid, a solar grid, for it to work in the same way. So all of these different energy transformations goes back to how energy is, there's different types of energy, right? So with that, here we have question number 8, which you are going to complete on your own, and you're going to match the terms of energy, the different types of energy to the correct definition, okay? Let me know when you are finished by clicking on that activation link. And remember, you can go back and check in questions, in the previous questions to find the correct answer. For example, endothermic and exothermic are both found in question number 2. And question number 6 has potential and kinetic energy. Okay. Thank you, Jordan. Thank you, Owen. Thank you, Kayla. Thank you, Olivia, Thomas, Vanessa, Joaquin, Jesus, Bobby, Cyrus. You good? Ready, ready, ready? Perfect. Okay. So that's question number 8. Okay. Now, do you like roller coasters? Um, What's the scariest part of a roller coaster? Where are you moving the fastest? And where do you think you're moving the slowest on a roller coaster? Tell me, tell me, tell me. What do you think? Anybody? Do you guys like roller coasters? Um, I used to. I used to love roller coasters. Um, Now I have to say, I don't enjoy them as much as I used to. Yeah, crazy, right? Most people say at the very, very top of the roller coaster, right before you start going down the tallest hill, is the scariest. The place where you're moving the fastest on the roller coaster is at the bottom of that tallest hill. Usually it's the very first hill. And that's when you're moving the fastest. It is not in the middle, even though sometimes it feels like it. And then obviously, right, you're moving the slowest at the top of the hill, right? And that's when it's so scary because you can hear the links, right? And it goes click, click, click. Yeah, for sure. So remember that the law of conservation of energy says that energy cannot be created and it cannot be destroyed, but it can be transformed from one type of energy to a different type of energy, and it can also be transferred from one place to another place. Okay. So that chemical energy in an apple can be transferred from the apple tree to me when I eat that apple. And then it can be transformed from a chemical energy into kinetic energy when my body digests the chemical energy from the apple and puts it to use in my muscles. Okay. Thank you, Jordan, Ola, and Kayla. I appreciate you. Thomas, how's it going? Bobby, Olivia, you doing okay? Awesome. Thank you, thank you, thank you. So again, this is question number 9. Okay, question number 9. So with that, if I look at the transformation, right? These energy transformations. If I start off and look at fuel that's used to move a rocket, the starting energy is a chemical energy, right? Stored in the fuel. Then that ending energy is kinetic. Because again, kinetic means moving or motion. Okay. If I digest food to make my muscles move, again, same thing. It's chemical energy going to kinetic energy, right? The chemical energy that's in food is being changed into the movement of my muscles. Okay. Here's 2 more examples, right? If I have water in a dam, right? And the water is up at the top, and it's released and it flows down into the bottom pool, the lake, that's going to produce electricity. So that is going to be a type of potential energy with the water sitting up at the top, right? And it ends in electricity. And then I have solar cell, which captures sunlight to produce energy. Again, that is going to be light energy being converted into electricity, right? Okay. So these, again, are all energy transformations. So here are 4 types of energy transformation. And you get to choose which of the transformations are related to each one. Okay. Notice that in this example, it says falling water. So that water is moving, right? It's not being stored at the top. Thank you, Olivia. Thank you, Jordan. Thank you, Kayla. How's it going, Bobby, Olin, Thomas? You ready? Thank you. Perfect, perfect, perfect. Okay, so that's question number 10. Okay, question number 10. Now, when I talk about potential energy, remember that is a type of stored energy due to its position, right? And when that object is released from its position, then it changes into kinetic energy. Just like we were talking about the water being held in a dam is a type of potential energy. And then once it's released and begins to fall, then it gets changed into kinetic energy. Okay. Perfect. Thank you, Olivia. Thank you, Kayla. How's it going, Jordan, Thomas? Doing okay? Perfect. Thank you, thank you, thank you. Awesome. Okay. So when we look at how potential energy is changed in kinetic energy, a dam is a great example of this, but a roller coaster is also a great example. Okay. I know that when the roller coaster is at the top of the hill, that is when I have the most potential energy. So at that point, when that car is at the very, very tippy top, I'm going to have 100% potential energy. And there's a moment where the car kind of pauses, and right before it starts to fall, it has 0 kinetic energy, and that is at the top of the roller coaster, right? At the very, very bottom of the roller coaster, it's the opposite. There is 0% potential energy because it's at ground level. And now it's got 100% kinetic energy at the very bottom of that hill. In the middle of the hill, I'm going to hit a position where there's 50% potential energy and 50% kinetic energy. And that is the answer for question 12. Okay. And you can see that the potential energy increases with the object's height, but the kinetic energy increases with the object's velocity or the speed that they are traveling. Thank you, Kayla. Olivia, you good? Thomas, Jordan, Bobby, doing okay? Thank you. Thank you, thank you, thank you. So again, this is for question number 12 and question 13. Perfect. All righty. So question 14 is going to be complete on your own. Here we have like a roller coaster, okay? You can see there are 4 points. At the very top of the hill is A. At the bottom ground level is B. A smaller hill at the top is C. A little dip, but not quite at ground level, is D. And then a third little mini hill is at E. Okay, so where's the most potential energy and the least amount of kinetic energy? And where is the most kinetic energy and the least potential energy? Olivia, you got it. Yes, absolutely. You're on fire. Good job. Perfect. Bobby, you good? Thomas, you good? Thank you, Jordan, Kayla, Olivia. I appreciate you. Yep, perfect. Okay, that is amazing. Okay, what I want you to do is go ahead and submit these notes, okay? And then we are going to have a work day for this afternoon. Okay. There's several of you that haven't quite finished the Unit 2 exam, and we need to get that taken care of. So I look at the chat box because I am going to be sending you a message, okay? But I'm going to go ahead and put this up, okay? And I need you to click on one of these links on our class, what you're going to be doing for the remainder of this time period. A is I'm passing and I don't need help. B is I'm passing, but I need some help on the assignment. C, I'm not passing, but I know what I need to do and I don't need help. D, I'm not passing, but and I need help. Okay, so click on that for me. Okay, and again, watch your message because I'm sending you some messages here. Okay. Okay. So everybody should have a message in your chat. Okay. And now you've got something to work on. So I'm going to bounce around and see if you need some help. Okay. Do remember that the exams are the most important assignments, right? Okay. Okay, you guys that are here. Hello, hello, hello. Let me know if you need any help. Otherwise, I'm going to sign off in about a minute. Okay, so again, let me know if you need me. Okay.